Hello everyone, this is Naimisha of Group C10. My team members are Priya and Mercy. Today I am delighted to introduce you to our project on skin cancer detection using convolutional neural network under the guidance of Sailaja ma'am. Our project aims to classify benign and malignant skin diseases using machine learning techniques to diagnose cancer at early stages. Coming to the abstract, skin cancer is most common cancer affecting millions annually with survival rates dropping as the disease progresses. Early detection is crucial but often costly and complex. This paper proposes a new method for classifying skin lesions as malignant or benign using images from standard cameras by leveraging deep learning and neural networks specifically analyzing dermoscopic images. This approach aims to enhance early invention, reduce morbidity, and save lives. Coming to the scope of our project, the scope of our project involves data collection in which we gather dermoscopic images, then pre process the data where we prepare and clean the data for analysis. After we choose and train deep learning models, then we assess model performance, implementing model for use, then we iteratively refine the model ensuring privacy and consent. Coming to the existing systems. Skin cancer classification typically uses dermoscopic imaging devices and machine learning algorithms such as SVM and KNN. Test datasets are often provided via static CSV files that contain pre-processed data. Computer-aided diagnosis software helps dermatologists analyze dermoscopic images, improving diagnostic accuracy. Then, the proposed systems are advanced deep learning using CNN with Inception v3 improves skin cancer diagnosis by automatically extracting complex features from images, increasing accuracy and efficiency. The system provides an accessible platform for capturing and assessing skin health, detecting various skin conditions with greater precision. The hardware and software we used in our project are coming to the design of the project. The use case diagram, the flowchart inside the slide represents the process workflow for a data scientist working on a machine learning project where the scientist begins by downloading dataset from a source. Once the downloaded dataset is extracted, if it is compressed or needs to be unarchived, then metadata about dataset is generated in CSV format, after which the dataset is loaded into a suitable environment for analysis. In this process, pre-processing steps are involved, where we prepare and clean the data for analysis. The data scientist builds a model using pre-processed data involves selecting an appropriate algorithm and setting up an initial model. The built model is trained on dataset. The best performing version of model during training is saved as a checkpoint. The second use case diagram illustrates the interaction between a data scientist and end user with a machine learning model data. The class diagram 1. It has two classes, dataset manager and data preprocessor. Each class has its methods listed. Download and extract. Downloads dataset from a specific source and extracts if it's compressed. Generate CSV. It generates a CSV file from a given folder, possibly mapping labels to integers. Decode image. Converts it from raw to a usable one. Preprocess path. Likely prepares it for use in a dataset. Show batch. Shows a batch of data useful for visualization and debugging process. Class diagram 2. It illustrates the structure and functionality of the system, highlighting how the skin cancer model class is responsible for building, compiling, training, and predictivity with the model, while the model evaluator class is responsible for evaluating the model's performance through prediction, confusion matrix plotting, and ROC AOC plotting. Coming to the sequence diagram. In sequence diagram, there are three participants: user, UCF101, UCF video analyzer. User is an end user interacting with system. UCF101 is a dataset which contains UCF101 videos. UCF video analyzer is responsible for analyzing videos. The user interacts with UCF101 dataset to select and download a video. The UCF video analyzer handles the download, preprocessing, conversion to GIF, and action prediction. The user is provided with a list of videos, selects a video, and receives the predicted action from the video. Activity diagram 1. This workflow guides through the steps from downloading the dataset to preparing it for training and displaying sample images. First, we download and extract dataset, then generate a CSV file for training data, then generate a CSV file for validating data, then again we generate a CSV file for testing the data. Then we load the CSV files into data frames, then convert the data frames into TensorFlow datasets, map the dataset using process path function, prepare dataset for training process, and lastly we display the batch of images from the dataset. The activity 2. This workflow details the steps from building the model to making predictions and evaluating its performance. Coming to the system architecture. In this, the architecture shows for a skin image analysis pipeline. The user uploads a skin image, then the system acquires images from the user. The acquired image is pre-processed to enhance its quality and sustainability for analysis. The pre-processed image is segmented to isolate the region of interest. Features are extracted from the segmented image to be used for classification. The extracted features are passed to a classifier which predicts the class of the skin lesions. The classification result is obtained and passed back to the user. The source code of our project. Firstly, downloading and extraction is done. Then we generate it into CSV format. Then we tested and trained the models where it gives the total number of training and validation samples. Then it reads the image size. Here we have uploaded the image datasets. Then we build the model by featuring inception v3 and pre-trained weights. Then we evaluated the model. Then we use the confusion matrix for the prediction to calculate sensitivity and specificity. After that, ROC curve is determined in the graph given. Then the final output, which says 89.90% benign, which means the skin lesions used for testing is not 90% affected by the disease. In other case, if the disease is present, it shows malignant. Coming to the conclusion. Skin cancer detection involves stages like preprocessing, image segmentation, feature extraction, and classification. The choice of classification technique is crucial. CNN based systems show promise but have no limitations, such as dependency on dataset quality, class imbalances, and biases. Ensuring diverse representative datasets is vital to reduce biases and ensure performance across different skin types, while CNN advanced medical image analysis by potentially improving early diagnosis and outcomes. Further research and collaboration with medical professionals are needed to address limitations and integrate this system into clinical practice effectively. These are some of the references we used for our project. Thank you.